So another problem here. This one involves two masses. The mass one on the table, it's telling us this table is frictionless. So there's no friction to keep that mass from sliding. But we've gotten that mass rotating, so it's moving in a circle. So there's tension in the string here. And that tension is in the string down at the bottom as well that's holding mass 2 up. We want mass 2 to remain hanging at rest. So mass 2, just to draw my free body diagram, there's tension in that string that connects it to mass 1, and there is the force of gravity. This specific problem wants that mass, or this mass, I should say, to hang at rest. So at rest, there's no acceleration for the hanging mass. So no acceleration in the y direction. Thus, tension has to equal m2g. Now, mass 1, if I were to draw a picture from the side, I know there's tension in the string that's pulling on this mass towards the center. It, of course, has a normal force and the force of gravity. There's no acceleration in the up and down, the y direction, so we can say that the normal force has to equal m1g. But the tension is the only force horizontally in this picture. Because this mass is moving in a circle, it's going to have a centripetal acceleration pointing towards the center at all moments in time. So we can say that this tension, since there's no other force along that radial line, the tension needs to equal this mass times the centripetal acceleration it has. And again, we know it has a centripetal acceleration because its direction is constantly changing. It's moving in a circle. All right, so coming back, we want to know the speed m1 must be rotating at to keep m2 hanging at rest. Speed comes into play because centripetal acceleration is equal to v squared over r. So the tension in the string needs to equal m1, the mass of this block, times v squared over r, which represents the acceleration. But again, we want the speed such that the hanging mass will stay at rest. So we want the tension to equal m2g to keep the hanging mass at rest, but it has to equal m1 v squared over r to keep the mass on the table moving in a circle. We're looking for v here. So I can bring the r over, divide by m1, take the square root. So the radius is 3.3 meters. m2 is the hanging mass. It says that's 11 kilograms. G is 9.8. m1 is 4. I'm getting 2.8 meters per second. That's how fast the mass on the table needs to be moving in that circle in order to keep that heavier mass hanging at rest.